Hey guys, this is going to be another quick video for optimizing a Fibonacci program, Fibonacci, whatever you call it. So I just had this in an interview. I used a dictionary, but then I just found that there's another cool inbuilt feature which I could use. So just going to share that with you. Uh, so starting with the Fibonacci thing, I used a recursive approach. I'll just do that here quickly. So the question, the problem statement was that they'd give me any numbers and input, and then I had to print the Fibonacci sequence for that. So I just wrote a very simple program there. I'll just define a function, and I'll just say yes if the input I get is 0, just return 0 for me. Similarly, if input is 1, you give me 1, and if n is equal to 2 again, you give me 1. So yeah, people could argue here that some say Fibonacci series start with 1, 1, 1, 2, and so on. Uh, so the interviewer, he asked me that it should start like this: 0, 1, 1, 2, and so on. So that is why these three conditions here. All right, so I'm just going to tell you here's what I did then. All right, this is okay. And again, if it's greater than 2, oops, if it's greater than 2, you just do a recursive approach and return to me the sum of its last and the second last number which is there. Pretty much a very simple recursive approach for this. So this was the function which I wrote. This would work. It would run into some issues that I'll just discuss right now, and then I would just do for variable in range. Let's just say 10 for now. So this was the thing that the user would input, or maybe they'd change this number randomly. Just say assign this function here, and then I'm gonna print. I could print it directly as well. This is a bit more readable for me, so I do it this way. All right, let's do this. So yeah, once this happens, I get like a pretty similar thing here. You know what? I'm just gonna end it with a change it with a comma. Let's see. Let's do that. Yep. Come on, this looks bad as is, but anyway, yeah, this would be the command output here. So let's you know what, let me just add the time here as well. Let's see the execution time. Just import time right there, time. Okay, let's say okay, let's define a start time. Let's say time would be say time. All right, once all this is done, okay, I'll just remove this. This does not look good. Once this is done, I'd say I'll just go ahead and say that print time taken. I'd say maybe, you know what, stage s seconds. And let me just use that format thing here quickly. That would be the current time minus the starting time. So I can just say time dot time, whatever the current time was, subtract from that my start time. It looks okay to me. Let me just do a control L on this, save this, run it again. Okay, it took like, okay, ran very quickly. But the thing where this program tends to run into a problem is when we keep on increasing this. If I make it 20 right now, run it again, uh, that was also fine. I would say 30. Run it again. Okay, you see the time in here is increasing. Let me just make it uh, 35 right now, and let's just run it again. So now the problem starts here. So the execution again starts taking a lot of time because there are a lot of recursive calls being made here. If I do it, say 40 now, this would again take some time. Let's see. Yep, it's still running, still running, still running. Still running. Okay. How much is this if I just select it? All right, took almost 20 or 27 seconds. All right, so this was how they asked me to optimize it. I did a very standard thing there. I initialized a dictionary, and then I just wrote an if condition here that whatever value is being returned, it should just put uh, I mean a key value pair in the dictionary. So if the input is 1, it should if the input is I did not do it for these three cases, but say if the input here is 3, you give me, that would be 0 plus I mean that would be n0 plus n2. So I did that. This was okay, but the again code became a bit unreadable. So later on, I did some research, and there was FuncTools has an internal implementation of LRU cache, which works pretty similar to the dictionary approach. The lookup speed is almost constant time there. So I'm just going to share that. So here's what I did in that case. What I did was from function tools import LRU cache, and the very simplest of syntaxes it has is you just write at LRU cache. You cache, you just define the cache here, and I'm just going to give it a max size. I'm not sure by default what its max size is. Which is okay. If max size set to none, then it can grow without any bound. We don't want that. Let me just let me just set a max size of let's just say okay, we have sufficient RAM. Let's just say 1000. All right. So let me run this right now with 40. Initially we took 27 seconds. Let's see what happens right now. So yeah, you see that the speed up is exponential now. Even if I were to do this with say let's do 100, why not? Even for 100, it's not crossing a second. I mean, not even a second. Let's say 500 now. Not even a second. Awesome. What if I do 1,000 recursive calls? Still not. And again, if I were to just comment this out right now and even um, do a standard recursive solution for 50, that would run into a lot of problems. This would take more than a minute, I guess. Definitely more than a minute, because these values are not being stored anywhere, and they would have to I mean, they would have to be computed again and again. So this dictionary was one way. I'll write and upload the code for this on my GitHub as well. But I think this is the most easy and the most readable thing that is there. So, and again, there's one thing which I always say in the interview that I mean, if there's an internal library, if it's something that comes pre-built with Python, I'm going to use that. Uh, because if somebody smarter than me has already written a library for it, why not use it instead of reinventing the wheel every time? So yeah, this is something which was very good. You guys try using this as well. In most of the recursive cases, this should work. So yeah, let's just do it for 5,000. Let's see. Oh yes, oh yes, for 5,000, not even half a second. So yeah, LIU cache is good. Try using that. I'll put the link to this code below in the description, and thank you for watching.